here to tell you about action potential. Neurons send messages electrochemically. This means that chemicals cause an electrical signal. Chemicals in the body are electrically charged, and when they have an electrical charge, they are called ions. When a neuron is not sending a signal, it is considered at rest. When a neuron is at rest, the inside of the neuron is negative relative to the outside. Although the concentrations of the different ions attempt to balance out on both sides of the membrane, they cannot because the cell membrane only allows some ions to pass through. At rest, potassium ions can cross through the membrane easily. Sodium ions cannot cross through the membrane. The negatively charged protein molecules inside the neuron cannot cross the membrane. In addition to these ion channels, there is a pump that uses energy to move 3 sodium ions out of the neuron for every 2 potassium ions that it puts in. Finally, when all of these forces are balanced out, you have the resting potential. The resting membrane potential of a neuron is about negative 70 millivolts. This means that the inside of the neuron is 70 millivolts less than on the outside. The resting potential tells what happens when a neuron is at rest. However, an action potential occurs when a neuron sends information down an axon away from the cell body. The action potential is an explosion of electrical activity that is created. This means that some event, such as scratching your face or wiggling your toes, causes resting potential to move towards 0 millivolts. When depolarization reaches about negative 55 millivolts, a neuron will fire an action potential. This is the threshold. If a neuron does not reach this critical threshold level, then no action potential will fire. When the threshold level is reached, an action potential of a fixed size will always fire for any given neuron. For any given neuron, the size of the action potential is always the same. There are no big or small action potentials in one nerve. All action potentials are the same. Action potentials are caused when different ions cross the neuron membrane. A stimulus first causes the sodium channels to open. Because there are many more sodium ions on the outside, and the inside of the neuron is negative relative to the outside, sodium ions rush through the neuron. Sodium has a positive charge, so the neuron becomes more positive and becomes depolarized. It takes longer for potassium channels to open. When they do, potassium floods out of the cell and reverses the depolarization. At this time, the sodium channels start to close. This causes the action potential to go back towards negative 70 millivolts. The action potential goes past negative 70 millivolts because the potassium channels stay open a bit too long. Gradually, the ion concentrations go back to resting level and the cell returns to negative 70 millivolts.